Okay, we're live. Okay, sorry about that. It's a little bit confusing back here. Okay, so this is actually the talk with three titles. So there's the title that you just heard that we submitted, and then a few weeks ago now, we did an internal talk that covered a lot of the same stuff, and we thought had a really nice narrative. So we decided to do that for this talk, and I gave it this title for the internal talk: Document Relational Convergence and EFCore 8, which, to be honest, even though I wrote it, is a bit pretentious and I don't really know what it means. So really, with the new EF8 phone with JSON. So that's all you need to know. Okay, but we are going to talk about document versus relational databases. Document databases are good at some things, and relational databases are good at some things. EFCore comes into the picture by leveraging commonality between these two. So we want to enable common patterns. So for example, regardless of your database, you can write a link query, pull back some data, make a change to that, call save changes, and save the unit of work back to your database. But we also want to leverage the specific power of each database system. So where a document database is good at point reading an entire document, we want to make EFCore function in that way and make it possible for you to effectively read the entire document when you're using a document database. And in fact, going further than this, we want the way EF works to promote the best practices for the database system you're on.
So that raises an interesting question, Arthur, which we get a lot. Does that mean that we can treat EF as a sort of abstraction over your database in the sense that we can swap out, for example, I'm using SQL Server and I can swap it out to use something like Cosmos and my code will just run as it is? Can that work?
So that's a very good question, Shai. And the short answer is no. And the reason is because we want to leverage the power of the different systems and behave differently depending on the backend database. But enough slides. Let's go and actually look at some code. So code, yeah. So I've got a very simple model here. It's a customer entity type. It's got some details, and the details have lists of address and phone numbers. And then I've got an EFCore DB context here. So this DB context basically is the way EFCore connects everything up and tells us how to map to the database, what the model is, and everything like that. In particular, we're saying use relational database. In this case, I'm running a local SQL server, and we're telling it to map this customer object to the database. Now, we're not telling it explicitly how to map the rest of these things, the nested things in here. We're going to let it do the appropriate thing for whatever database it's using. So initially, a relational database. And I have just a little application that's going to cleanly recreate my database. It's going to insert 3 sample customers and call save changes. So let's run it. Hopefully works. First time running live code. And you can see that EF has created 4 tables for this mapping. So let's go look at that. Shai, what's going on here?
Right. So anybody who's familiar with relational databases will find this very, this is just a classical thing. What EF does here, it maps your code model in .NET to 4 tables in your relational SQL database. Very classical. You've got a table for the customer, for the customers, for the customer details, the addresses, and the phones. The thing to understand here is that a single customer, the data for a single customer is sprayed across 4 tables. That's the relational way to think about it. All the addresses for the customer go to one table. All the phone numbers go to another table. You've got, the main stuff in the customer table, and they're all linked together via what's called foreign key relationships, right? There's foreign keys and primary keys and all that classical stuff, right? So nothing to write home here. This is the way EF has worked since forever, and that's how most ORMs do their job.
Right. So let's go back to the code now, and let's actually change this context. And the only thing we're going to change here is we're going to say actually use a document database instead of a relational database. And for this, we're using Azure Cosmos DB. And so I'm going to run the same code, but just against the document database now. And actually, when this runs, you should see that the output is quite different to what it had before. Visual Studio is messing up the output there. Let me close it and run it again. Okay, here we go. So before, remember, it created the schema. It created those 4 tables. Document databases don't have a schema, so there's no tables to create. So you don't see any output for EF doing that. It did create a Cosmos database for us to use in the background using the emulator, and it inserted 3 customers into there. So let's go look at what that looks like in the database, Shai.
So very, very different, obviously. Instead of getting four tables with the data spread across, what we're seeing here is a single customer represented as a JSON document. So typically document databases, you can think of them as representing the data in JSON, even if it's not always exactly what goes on and behind the scenes. But the main point here is that document databases represent hierarchical structures of data. So you have your customer things, and you can see the addresses and the phone numbers and everything inside one single document. The crucial point here is that the related stuff, again, the addresses and the phone numbers, are co-located. They're inside, they're contained within that one document rather than connected to it via foreign keys or all kind of things like that. And of course, we also have the other documents for the other customers. So instead of having rows across four different tables that represent the customer, we have one document for one customer, another document for another customer, and a final document for the third customer. And I think that illustrates, for anybody who's unfamiliar with document databases, this is a great comparison to kind of understand that it's very different strategies for modeling your data. And we're going to see how that's going to affect things now.
Right. Okay, so let's go back to the code. And what I'm actually going to do now, remember we said document databases are good at certain things. And one of those things was point read of an entire document. So I'm using my document database here. And in my application, I'm going to go and say, okay, well, let's bring back a document. So I've got this query that's going to say, bring back one of those documents with the name Baxter. And then we're just going to drill down into Baxter just to show that we've got everything back. So we're going to print out the number of addresses that Baxter has. So when I run this, hopefully we should see fairly reasonable output. So we're running, we've executed a query against the document database to bring back that one customer. And indeed, he has two addresses because we brought back the whole document there. So that's what we kind of expect from using a document database. That's EF's behavior for that. But what happens now if I do that thing that Shai said and that we get asked? What happens if I take my really simple application, all it's doing is bring back Baxter, right, and outputting the addresses? What happens if I switch out that and put a relational provider behind it? So I'm going to do that by opening the context here again and changing this to use SQL Server again instead of use Cosmos. So we're going to go back to creating those four tables that we saw before. So when I run this, what we get at the bottom is a null ref exception. Shai, why are we getting a null ref exception here?
Right, it's a demo. Why are we getting an exception, right? So we actually planned for this exception. This is not a failure in our demo. The thing is, when you use a relational provider and you instruct EF to get the customers, what EF will do is not get the entire customer graph, including all the addresses and the phone numbers, because those are actually over there in different tables with all the foreign key relationships and everything, right? So what EF will do is only bring back the data from the customer table itself. And then if you take that customer and attempt to drill down into the address, they're not populated because EF hasn't loaded it for you, so you get a null reference exception.
But Shai, I can fix that, right? So, sure, we don't want to bring back all of the data because it's, not best practice to do that. But if anybody's used EF, they know about include, right? Include just says, okay, bring back the details and the addresses and the phone numbers with this query. So if I run that, we shouldn't get a null ref exception anymore.
That's right.
And indeed, we don't. So it's all good.
Exactly, because you've now explicitly instructed EF to load the entire graph, or specifically the addresses and the phone numbers and so on and so forth. However, it's worth examining the SQL. Always a good idea to examine the SQL, by the way, even though you're using LINQ to express your queries. So if you look at the SQL, you'll see that we have three joins in there, which correspond to those three tables, right? Because as we've repeatedly said, data is spread across different tables, and loading the entire customer implies bringing in data from other tables. Now, joins are actually quite a big thing for a database to do. It implies a lot of work. The database has to go to the other table, find the exact row that corresponds based on the foreign key relationship and all that kind of stuff. So that is exactly why EF doesn't do it for you by default when targeting a relational database, right? You have to say that you're interested in those addresses. If EF were to bring back the entire graph all the time, then performance would be absolutely awful, because that's not how relational databases are meant to be used. And I think that really illustrates, once again, that point that we made before. each database has its strengths and weaknesses, and you definitely cannot just take a relational database and use it like a document database, or vice versa. Sometimes people porting applications between the two database types attempt to do this kind of thing. They think they can swap. They can't. It doesn't work like that.
It doesn't
Absolutely
work.
not.
But Shai, and this is where that word convergence comes in from that one of the titles to this talk, because
that pretentious
basically.
word.
Yeah, that pretentious word. So it's basically the competitive environment that exists now between document databases and relational data, all NoSQL databases, but document databases and relational databases is what we're focusing on. And it's pushing document databases to do better at things that relational databases are traditionally good at, the transactionality, that kind of thing. And likewise, the fact that document databases are so good at dealing with documents and doing this kind of scenario is pushing relational databases to have support for document capabilities in that. And so what we're actually going to do is change the mapping in EFCore now in the relational database. So let's go back to the code. So I'm going to open
to go into the cool territory.
Yeah, so I'm going back to my context here where I'm using SQL Server, and I'm saying, oh, actually, okay, map that differently. We don't want 4 tables. For our scenario that we're doing here, we still want a relational database because there's lots of other data here. But for this particular customer and the customer's information, we actually want to be able to bring that back very quickly as a point read. So I can tell EF, okay, well, when you see customer, bring back details, addresses, and phone numbers automatically. And, oh, by the way, map this to JSON in the relational database. So this is actually going to put it in a JSON call, in a relational column. It's going to create a document there. Before I run this code, I'm just going to change 2 other things. So I'm going to remove the primary keys from these nested types because they're not actually needed when you map into a document. They weren't needed, by the way, for the Cosmos one either. I just didn't remove it for the sake of time there. But
right,
now
these things are embedded inside the document, right? There's no foreign keys and primary keys now, so there's no need for keys.
There's no need for keys there, exactly, Shai. And the one last thing I'm going to do is go back here, and I'm going to remove these includes because we've told EF, bring it back always, right? So now, hopefully, if I've done all the things, we run this again. We'll see completely different thing happening. And the first thing we see is we're not creating 4 tables anymore. We're creating 1 table. So Shai, what's happening here?
Right. So no more 4 tables, right? Which I think will mean no more joins. But that single table that we now see has this column at the right edge of it called details. And what is inside that details thing for each customer is a JSON document containing all that data that we map to it. So what we're effectively doing here is establishing some sort of hybrid model. This is a relational database. This is SQL Server. But we're now embedding a JSON document, so kind of a document database sort of way to model data inside a column in that relational database. And that allows us to mix and match, right? Like a while ago, people used to say, it's either relational or document or NoSQL versus SQL. So that is not the way things work. Definitely not anymore, right? You don't have to choose one or the other. You can actually, that's the convergence part. You can use a relational database with some, document features and also vice versa, which is what you're seeing here. And crucially, this also gives us, as Arthur said, the way to work. If my data is good for modeling in this way, and I want to just get it back in one single, thing without joins, then this is a perfect way to do that. And it doesn't mean that I can't have other relationships in a more traditional relational way, right? So mix and match.
Exactly. So speaking of that, this is the query. You can see we're not doing any joins. So this is a very efficient query that's going to bring back all the details from the Baxter and his addresses. And of course, it doesn't null ref because we've got everything.
Right.
So that's very cool. One of the things that makes this possible, there's really 2 things that make this kind of thing possible in EFCore, and that's what we're going to dig down to. The first is that EFCore has a rich model, and so it knows what's behind these things. So it knows what's in that document. And the second thing is that relational databases, and this isn't just SQL Server, all major relational databases have first-class support for manipulating and looking into and doing things with JSON documents. And so, as we'll see, this isn't just a serialization of stuff into an opaque column, right? This is a lot more than that. And we'll start looking at that by actually running some a little bit more interesting queries on this. So I'm going to replace this here with a query. So Shai, what's going on here in this query?
So just a normal link query, right, for EF. But there's actually something very interesting happening here. Recall that the seed details that you see in that where operator actually maps to a JSON column in the database, right? This is not a normal column. And the region property that you saw, dotted inside there actually refers to a JSON property inside that document. So if we switch back to the query, what we're actually asking EF here to do is to filter our customers based on something that's a JSON property inside a column, right? That means that the JSON has to be able to parse to actually understand that JSON inside there in order to do this efficiently, right? This couldn't be done. Like, you can't do this if you just kind of dump JSON into your column. That doesn't mean you can search based on the contents inside, because the database has to understand that kind of stuff. So let's run this link query and see what happens.
Okay.
It's going to get more and more exciting.
Yes.
Very cool. So EF here is leveraging a SQL Server function called JSON value. This is exactly the kind of thing where Arthur said that relational databases are getting JSON support. This is it. This is the kind of thing. JSON value is a simple function. You give it a JSON document. Here, that's the details column containing our JSON document. We saw that just before. And you give it also a path inside that JSON document to a property, to a simple property, and it will extract. So it basically parses that JSON document, gets that region, extracts it, and then we can compare that to Europe, effectively asking the database, get me all customers where the region is Europe, basically. Very simple, just works.
Okay, excellent. So I think that one, so that one worked in EF7 because this journey we're on implementing JSON support is kind of a multi-year thing, and we're a relatively small team. So that was something that worked in EF7, but in EF8 we've really ramped up what's available, and this is a query that didn't work in EF7 but now does work in EF8. Shai?
Right. I'm very excited about this specific feature that we're delivering. So we're again looking at C details, which is a document, but instead of looking at a scalar property inside the region from before, we're now looking at addresses, which is an array. So that's a JSON array. And because it's a collection, we can now compose a link operator, any, on top of that thing, and effectively ask the database for all customers where there's at least one address in the UK, right? Once again, we're composing link operators on a JSON array that's inside a document that's in a column. That's starting to get a little bit complicated here, but I hope everybody's kind of right. But very cool.
Let's see what it generates, because exactly. I think it's easier sometimes to understand some of these things when you see the SQL.
Possibly. Sometimes it's even more complicated, though. So here we have another JSON primitive of SQL Server called OpenJSON. Now, OpenJSON, a bit like JSON value that we saw before, you give it a JSON document, that's the details, and you give it a path just like before. But the path in this case is a path to an array of JSON things, not a scalar. And that array contains various objects with properties, the addresses. And what we're saying here, EF knows the structure. So once again, we have a rich model. We know what's inside that JSON array. So we instruct SQL Server to parse out that JSON array as a relational table. This is a sort of a transformation from JSON into a table, what is effectively a temporary table. We're telling SQL Server what the actual schema in there is. So we're saying each one of those elements in the JSON array has a city, a country, a postcode, a street, and so on and so forth. And these become the columns in the new relational array that gets transformed out of this array. And once we have that table, it's just a table in a normal relational world, and we can put it after a from, like in SQL, and then we can use where to filter on the country where it's only in the UK, and so on and so forth. So we've transformed a JSON array nested inside some document into a table, and then use that to filter on the customers that we want to extract.
Very cool. Okay, so we're gonna take a step into the unknown now, because this is a query that we just threw together literally like 10 minutes ago before this session, which is also a no-no on a big conference, right? You don't throw it together and hope it works. But
you only live once.
This is so you can talk to it and then we'll run it and see whether it actually works.
So we have not even tested this, but I'm confident that this is going to work. So what you're seeing here is something that goes in the same direction, right? We are going into the details thing, but at this point, we look at the addresses and we compose an any operator on top of those addresses. And we also project out things from outside of those addresses, right? So we're composing operators both in the where clause and also in the projection in the select operator, right? We're going to fetch all customers where there's at least one address in the UK, and then we're going to project out the first one that is in the UK, right? So let's give this a try.
We'll give it a try, but before we run it, this is actually, even if this doesn't work, this is something that, quote, does work in EF8 now, which didn't work in EF7 again, and that's projection of parts of a collection inside a JSON document, because that's another thing that's like really kind of important for this being able to work with a JSON document inside a relational, or in fact inside a document database. You need to be able to sometimes just select a part of it and bring it back, because you don't want everything. And so this is going to try and do that, hopefully. It's a fairly complex query if it works. So there we go. It worked.
It does actually work, right?
Okay, you want to talk about this? This is definitely the case where it's not easier when you see the SQL.
Now, people have to be like a bit more expert in SQL in order to understand it. But the crucial part here is the where exists that you see below is the same thing we saw before. So we can actually disregard that. That's the same thing that we saw before. This filters out customers that have an address in the UK. But in order to get out, to project the part that we want, we use an outer apply. That's also called a lateral join in other databases like Postgres, which means for every customer that gets filtered here, that gets selected, we're going to kind of join. We're going to do a correlated join. That's an outer apply. And we're going to join against the open JSON, so against that table that's constructed out of that array. So I'm not going to spend too much time on this, but I'm just going to say we once again take out those addresses in table form and then join that with the customer so that we can project it out. So this is quite a lot of deep machinery going on behind the scenes to produce this query. But the lovely thing here is that you don't have to care as users of EFCore. You just use LINQ to express what you want, and we just do the heavy lifting for you.
So also I should say that perf is obviously a complex area, and there are perf issues and perf things, and all of these things play into it. So we're showing you some things. I'll talk actually last year, if you want to go look at it, we'll talk a little bit about the perf aspects of some of these things and where it makes sense to do joins or not joins. But we know perf is a complex thing, so bear with us on not going too much detail of the perf stuff in this talk. Okay, we're going to switch to something a bit different now. So this looks like some of the other queries we've done, but it's actually different, and it's different because of this property.
Right. So we kind of glossed over this before, but what we have on customer here is something that was not possible before with EF. We have a primitive of a collection of a primitive type. So datetime is what we call a primitive type. It's like an int or a string. It's not a complex entity type with a lot of properties inside. It's just a primitive value. And we just have a list of those. Now, this is something that people have been struggling with for, I want to say, decades with relational databases. Just the simple thing of sticking a bunch of ints on your table is actually not very easy, because relational databases just don't have the concept of an array or a collection. So what you do is you either stick them with commas, like comma delimited like numbers inside a string. Maybe you stick them in a separate table and do a one-to-many relationship, but that's complicated and you have a join, so performance problems. So it really is a very simple thing, but not very easy to do. So with EFCore 8, this is really one of the most exciting things that we're bringing for EFCore 8. You can just do a list of primitives, like list of datetime that you see here, or int or string, and EFCore will implicitly map that to a JSON array in the database. So this happens automatically. You don't have to actually configure it in any way. If you look at the database schema, then you see that we have this visits column, and you can see inside, this is a string column in SQL Server, or an nvarchar max to be precise, and it contains a representation of that list, right? Inside you can see representations of datetimes inside JSON. So this is a way to finally resolve that problem, but it doesn't just allow you to serialize those things, which you could already do before with commas. It also allows you to query them, because EF knows what's going on.
So here we're going to run a query. Yeah,
exactly. So we're going to ask for all the customers who have at least one visit. That once again requires the database to go and parse what's going on inside that array. Let's go see.
Okay, so let's run that.
So
Our
we're
old
seeing
friend OpenJSON again.
That's the star of this show for sure. It's not you and me, it's OpenJSON. What
Yeah.
OpenJSON here is doing, it's very similar to what we had before. We're giving it visits. The difference from before is before we used it on something inside the JSON document, and we also used it on an array of complex things, addresses with many, many fields. Here, what we're doing is using it on a primitive collection, which means that there's only one column in the table that comes out. The type of that column is datetime2, which you see that EF specifies, yeah, into OpenJSON. And then we just select the count of that and select those rows where it's bigger than one. So once again, parsing
Awesome.
inside that primitive collection and querying it.
And I want to point out when we look at this next query something that you've mentioned a couple of times already. This is not just a opaque list of numbers in the database or list of strings in the database, right?
Right.
Because EF has this rich model where it knows actually these are date times, and because SQL Server can then use that with the OpenJSON, we can do things that are very specific to the semantics of this list being actually date times and not something else. And
people have been storing, numbers with commas or dates with commas in for a long, long time. But then you can't do anything with it if you just stick it in the database. There's no way to ask your database to filter on something inside, right? Unless you do it via string searches or something. Anyway, so
here we also have parameters, right? Which is important.
Right. So this query goes even further. So we have the same primitive collection visits, which is a collection of dates, date times, and we're composing a link operator on top of that, any. But what we're doing here goes a step further. What we want to do is get all the customers where there's at least one visit within a certain range of years, right? So we're going to extract the year out of each one of those date times in that primitive collection, and we're going to check whether it's within that range. So this already goes far beyond, what we did before. It's worth mentioning before we switch over to the SQL that the actual from and to here are parameters. They're not literals inside the query. The 2010 and 2019, the from and to, they're outside the query, and that means that EF will translate them into parameters. That's going to be very important for our next and last code sample. So bear that in mind.
Okay, so let's run this one first. Okay, here we go. OpenJSON again.
OpenJSON again. We will see it once more. So we do OpenJSON on the visits. We instruct SQL Server to parse that out as a table of daytimes with one column containing a lot of daytimes, right? But then, because we know it's a daytime and you've instructed us to extract the year, we're going to use the SQL Server function date part to extract a year out of a daytime, right? Once again, we can do that because we know, we keep repeating this, but that's the cool thing. So we're excited about it. We know what's actually stored inside the database. So we can do that, what you just saw. And the from and the to that you saw before, those things that I just mentioned as parameters, you can see that they're not actually in the SQL. You can see those, placeholders there, the from _0 and the from and the to _0. They're sent out of band. They're not inside the SQL. That's important, again, for our next demonstration.
Okay, so we're really going to switch up gears now. So we're going to show a case where there's actually no JSON in the database at all, but JSON is integral to this. And this is actually fixing an issue that when we started on EF8, this was the second most voted issue on our repo. And so it's really cool that we're able to bring all of this together and fix something that has been a big problem for EF users. And it's not really anything to do with document databases or JSON.
Yep.
Shall I run this on 7 first?
Yeah, but let me just say a few words, just so that we can understand the query itself, and then absolutely we want to see what happened on 7. So this query is actually a very classical kind of query. We're going to ask for all customers whose member since column here is one of a list, so is contained within a list. So special days is a parameter, remember from the last query. So it's a parameter, but it's a list parameter containing various dates, and we want all customers whose member since is one of those things. So this is a very, very classical kind of thing. You have a bunch of IDs and you want all the rows that correspond to that have those IDs, right? Everybody knows this. Everybody has done this. You use the contains operator to do it, and it's remarkably complicated to do this in a relational database, once again, because of the lack of proper support for arrays. So now let's run this in EFCore 7 and see
run this.
What we did before.
Oh, yes, we're doing it in 7. Okay, I did run it in 7, so we did work.
You're doing great. Everything is cool.
Yeah.
So what you see here, our contains operator in link, we translated it predictably to in. So it's a very trivial translation, right? Where member since in, we open parentheses. And then the curious thing is that those values which you saw in the parameter list back in .NET are now actually present as literals or constants inside the SQL. So remember, a few minutes ago, I said that EF generally wants to put parameters out of band and not inside the SQL. And this is not happening here because there's no concept of a parameter array. Once again, because relational databases just don't have the concept of an array. Now, why is this a problem? This is where it gets interesting. So it turns out when you send a SQL query to the database has to do a lot of heavy lifting in order to execute it. It needs to parse that SQL. It needs to plan for how it's going to actually, perform that query. That's actually a lot of complicated work. So in order to make things go fast, the database has a caching mechanism. So every time it sees the same SQL, it knows, oh, I've already seen the SQL. I've already planned for it. So I can use the cache plan from the last time that I did this, right? So as long as you properly parameterize your queries and the SQL itself doesn't change, you're good. Everything is going to perform well. However, what you see here means that every time you run this query with different values in that parameterized list in .NET, you're going to get different. I'm glossing over. This is actually a very complicated thing, and performance-wise, it goes way beyond what I just said. It's actually more complicated, but I will say this is a big performance problem, and as Arthur said, this was our second most highly voted issue up until this release.
And it's also one of the most discussed issues. So if you're interested, that thread has a lot of analysis, both from people at Microsoft, people in the community who contributed to it, looking at all the potential performance things. So let's see what we came up with for EF8 on this, Shai. So I'm going to switch back to the EF8 and run the same query.
This is going to tie the whole talk together, you'll see.
Yes.
All right. Surprised that we see OpenJSON again? Probably not. We've been harping on this. So what happens here, as Arthur said before, there's no JSON in the database. We're not querying a JSON column like we did in the previous things. What we are now doing is using OpenJSON over a parameter. This is what you see in the parentheses here, the special days. So EFCore took your array that was in .NET and basically serialized it into a string with a JSON array representation. It packed the .NET array into a JSON array, and then it sent that to SQL Server as a string parameter. On the SQL Server side, we place this thing into an OpenJSON, which unpacks it back from JSON form into a table. So this is a way of sending pretty much a table, or more specifically, a primitive collection from the client to the database, which is something that's been notoriously difficult in general with relational databases. Again, very complicated subject. We're not going into all the nuances. Once that thing is unpacked as dates, we can once again use it in the normal way and translate contains to in. So we've worked around the issue, and now this SQL, that's the crucial thing here, is not going to vary. If you change the actual dates in the list, what's going to change is only that string parameter containing the JSON array rather than the SQL, which is what happened in EFCore 7, right? So now you have one SQL, no matter what happens with this query, perf win. Very good.
Excellent. Okay, that's really impressive stuff. So that's actually making use of the first-class JSON support in the database, the EF-rich model, together to solve a problem that doesn't actually involve any JSON in the database or any document databases. So that's very cool. Okay, let me go back to my slides here, and we've got a quick summary. So we've talked a lot about document and relational databases, the fact that they both have strengths, but the competitive environment is pushing them both to be better at each other's areas. EF comes into this because we're expanding on what we've done in previous versions to allow you to use patterns against both of those. And those can be common patterns, but they can also be patterns that are very specific to the type of database that you're using. And in particular, what we've dug into in this talk is how we're using the first-class support for JSON in the database. And by the way, we showed SQL Server, but this works in EF8 with SQLite and with Postgres, which will be released in a couple of days. And you can use the rich EF model together with that to do some very powerful query patterns. Shai?
Right. I mean, it's hard to cover everything. This is a complicated set of features. There's a whole lot of functionality being delivered for EFCore 8. This theme of primitive collections, we really did a huge effort on. As Arthur said, this also works in other types of databases. If you use this, by the way, on Postgres, for example, a primitive collection does not actually map to a JSON array because Postgres is the one database that does have a concept of array, like a native array in the database. So the same idea of a primitive collection in EFCore is actually going to map to a normal, like a non-JSON array. So it's not even stored as a JSON string in the database, but rather as an array type. And all of the rich querying capabilities map to array querying in Postgres with some very specific things, which is, I think, a testament to how the EF approach kind of works. We try very hard to be database agnostic and not code specifically for a specific database, but rather, build it with other databases in mind and so on and so forth. There's the collections of entities inside JSON is like new support that's happened. We also leverage, again, this primitive collection concept to work well with parameters. So you saw how we took a parameter, which was an array, and composed contains on it, which with this cool translation. You can actually compose any chain of link operators on top of a parameter that's an array. And that is incredibly powerful. You can even do that on what's called an inline collection. So you can do like a new array. You open the curlies, you put a thing there, and then you start composing join and union and any link operator. It's all going to get translated, which is all very new and cool.
Good stuff. Good stuff. Okay. So we talked about some specific things, but there's also a lot of other new stuff in EF8. I'm not going to go through this list. aka.ms/EF8 what's new. That's updated today. It's got detailed documentation on all the major things in EF8, plus runnable samples that you can download from GitHub to run. So that's EF8. Oh, one more thing. So we've talked about document databases. A few months ago now, we were approached from the people at MongoDB about creating an EFCore provider. So we have been working over the last few months with Damien Gard and the folks from MongoDB to create a MongoDB provider for EFCore. There's a link there, aka.ms EFCore-MongoDB, that goes to a blog post that has links to the announcement and the NuGet package and all of that kind of stuff. As you might expect, it works very like the Relational, the Cosmos provider, and I've got just a very quick demo of that here for you. So what we've done, it looks exactly like you would expect for Cosmos or SQL Server, except we've got use MongoDB, and then everything else is the same. So I'm just going to change to run that one. And then when we run this, what we've actually got is I've got Docker running in the background. It might not be warmed up. With a test container of MongoDB, and we're going to use EFCore to insert 3 documents into that. Here we go. And then we're going to use Mongo's low-level APIs to extract the BSON out of it and convert that into JSON that we can see. And here is that JSON. It's hard to see in the console, but I have a handy slide, of course. And you can see it looks very much like what you'd see in the Cosmos database, except it's got Mongo-specific stuff, and there's 3 documents because it's all co-located like it should be. Okay, so we're almost out of time, so we've got some questions in a minute, but thank you for watching this, everybody. We've been showing the work of the .NET Data Access team, which is me and Shai, but then also Andrew, Bryce, and Marisi, and then we've got our contributors as well. And there's 3 more EFCore talks from the community at .NET Conf. I've got the titles on there, so go check them out. And then there's a bunch of links, but really the only one you need is aka.ms/EF8. That'll take you to the blog post announcing it with the links to everything else. The code's on my GitHub if you want to look at it for today. And Shai and I do a live stream to YouTube and Twitch every 2 weeks. We've got one coming up in about 2 weeks' time where we'll do a tour of EF8 features. So hopefully you can join us for that. And we're done.